Okay, according to our books, our syllabus, we have two types of searching. One is binary searching and another is linear searching. So what is linear searching? Linear searching, actually it's a kind of sequential searching. Okay, you see. So linear searching algorithm is a kind of function which is used to find out data from the list. It's finding the data sequentially. So it's a simple algorithm and it's not suitable for the big amount of data. When we have big amount of data at that time, this is not suitable because it takes more times. Okay, it simply starts from the beginning of the list and it goes through it item by item until it find the items it is looking for or reach at the end of the list without finding the data. So if we see the algorithm, then its stage we have already seen that it will start from the first of the list or beginning of the list. So start at the first item of the list and it will compare on the items with the search item that we have given to search. And if they are not same or if they're same, then it will stop. And if they are not same, then it will move to the next item. And it will, if we have more data, then it will repeat from the step 2 to 4 until the end of the list is reached. That means it will check, and if it finds, then it will stop. In the step 3 we have mentioned here, it will compare, and if it get the data which is same as the search item, then it will stop. Otherwise it will go until it reached at the end of the list. I think this is a very simple algorithm, very simple. So if we see an example of a linear search, then it will be easy for us to understand this one. So say this is the list and we have some items on it. In this list we have some item and we have mentioned here 0 1 2 3. Actually this is the index number, we know. So what we'll do, say we want to compare the number, or we want to search the number 31 which is in the list, and according to the algorithm it will start at the first item. So it will start comparison with the first item. Is it equal? So the comparison, if they are same or if they equal, then it will stop. So we are watching here, they are not same, then it will follow the step 4. If they are not, then move to the next item. And it will repeat from the 2. Compare the item with the search item. So 10, 31. They are same? No. Okay. If they are same, stop. But they are not same. So again, it will allow step 4. Go to the next step. And it will go again to the step 2. Compare the item with search item. So 31 and 20. If they are same, then stop. They are not same, then it will go to the next step 4. If they are not, then move to the next step. Okay. Again, number 2, compare the item. Item is compared. They are not same, and they will not stop. They will go to the next step or next item. And now compare the item with the search item. Yep, they are matched, they are same. Now stop. The algorithm will stop its work. So very simply, it will start from the beginning of the list and it will compare item by item and until the end of the list. If we see the pseudocode, if we see the pseudocode of linear search algorithm, then according to the algorithm, at first it will set some positions, start to 0, and it will take how long we have to travel. So end point, what will be the end point? So according to the length function, it will find out the end position. And found is actually key which is used to break the loop. So at first it will send, please enter the search item. You have to write the number or the item or the name you want to search in the list. So it will receive by using the keyboard in the target variable, and it will follow or it will apply the while loop. Here says start less than equal end. While start less than equal end, that means when the start position and end position will not same, it will continue. And while found is equal to false. So if any one of these two breaks the condition, then the loop will break down or the loop will stop its work. So after entering into the while loop, it will comparison. So it will compare the item with the target item that we have that you have entered for the comparison. So if list is start, that means position 0 is equal to the target, the item we want to find out. Then what it will do? It will give the value true in the found variable, and then it will send target is in the list. Target means the number that we are trying to find out. It will say yes, it is in the list. And this condition, sorry, this loop function is end, and it has already taken found as true. That means if it get at the first position or if it get any data inside the list which are same to the target, then it will set true value to the found variable. As a result, the okay, as a result, the loop will break down. Okay, if it does not, then what will happen? It will increase the index number. Start plus equal 1. That means start plus start equal start plus 1. And the while loop has been finished. Suppose it didn't find the data or the target item that we are trying to find out. So at the end, it will give us a message. If found equal false, then it will give us message the search item is not in the list. That's it. So this is the way to find out data by using the linear search in the list. So if you have any question, then you can ask. So binary search, in binary search, middle item, the middle item of a list, at first it will find out, it will search the middle item and it will try to match with the target item. That means in binary search, the middle item in a list is repeatedly selected to reduce the size of the list to be searched. Another example of recursion. Recursion means it will call the same thing again and again that we have seen in the merge sort. If the selected item is too high or too low, then the items below or above the selected item can be searched. That means if it finds the middle item of the list is too much high, then it will try to find out the item in the left side. And if it is too low, then again it will find out the data in the right side of the list. But more important thing is that if we want to apply this method, then the list must have to be sorted. It says to use this method, the list must be sorted in ascending or descending order. It will not work on the unsorted list. But if we apply the linear search, then it will work on unsorted list. Okay, if we see the algorithm, then according to the definition, at first it will select the middle item of the list. If the middle item is equal to the search item, then it will stop its work. And if the middle item is too high, then repeat 1 and 2. That means step 1 and 2 with the sublist to the left. That means it will try to work, or it will continue its work at the left side of the main list from the middle. And if the middle is too low, then it will repeat the step 1 and 2 with the sublist to the right. That means from the middle point to the right side. And it will repeat the step 3 and 4 until the item has been found or all the items have been checked. So this is the theme. At first it will find out the middle point of the main list. If this is same as the search item, then it will stop its work. Otherwise, if the number or the item that we are searching is too much high, then it will try to find out the item from the middle point to the left side. That means with the sublist, left sublist. And it is too much low. That means the search item that we are searching is too much low from the middle. Then it will try to find out this one with the sublist from the middle of the with the sublist right side from the middle, and it will start or it will continue until it find out its item, otherwise end of the list. Okay, if you see the example, like we have a list and our target item is 13. I want to find out 13 in this list. So according to the binary search algorithm, at first we have to select the middle point of the list. So here the middle of the list is 31. It will try to match. If it is same, or if the search item and the middle item is same or equal, then it will stop. But 13 and 31, these are not same. The target item is too much, sorry, the middle point is too much high. The middle point is too much high from the target item. That is why it will find, or it will try to find out the data from the middle point to the left side. That means from 0 to 4, it will take as a sublist. And again, it will find out the middle point of this sublist. So 0 to 4, we have the middle point 2, and it will check again. Here also, the middle point is too much high from the target item. Again, the left side from the middle will be the sublist. So here 0, 1, 2, that means 5, 13, and 24. These will be the sublist, and find out the middle point of this sublist, which is 1, and the number that we are searching, this is also 13. So these are the same. So it will give us the message, yeah, the item is in the list. Okay, let's consider our target item is not 13, it's 61. Then what will happen? So at first, again, it will find out at the first time, it will find out the middle point of the list. So we know this one, this is the 31 and the 4 number item. So this is the 31. So the 31, or the middle point, or the middle value of the list, is too much low from the target item. So it will check the right side of the sublist, or the right side of the list as a sublist. It will take and it will compare. So from the 5 to 9, they have the middle point is 61. So from the middle point, it will go to the, again in the sublist middle point 61, and it will search. Yeah, they're the same. So it will stop its work because it got its value, or it got the same value in the list, and it will give us the message that the data is in the list. Okay, if we see the pseudocode, according to the algorithm, it will set a list, and it will set the start point and end point. That means how many data we have in the list, it will find out, and it will set the found. It will set the found option for as a key, and then it will give us the message, please enter your search item, and target item it will take from the keyboard, while is start less than end and found equal false, it will goes on, but it will continue its work. So at first, in the while loop, it will set the middle point to start plus n divided by 2. If list item middle is equal to target item, then found equal to, and it will give us message list, the number is in the list. Okay, this is the if condition. And if the target, it will compare now, which side if I didn't find, or if I don't find the same value at the middle point, then what will happen? I have to decide that which side I will go, left side or right side. So if the target item less than a list middle, then it will set the end is equal to middle, because the middle point will be the last, because from the first to the middle it will be the sublist, and it will again find out the middle, and it will okay, at the middle we will start. If it doesn't, suppose our target item like this is 61 and we have here 31, so this is too much low, we have to go to the right side. So if it is not less, then it will set middle equal to +1 as a start. Okay, and it will continue until it find out the result, otherwise it will search all the items. And finally, if it doesn't find any item in the list, suppose our target item is not in the list, then it will give us message the search item is not in the list. This is the way to find out the item by using binary search. So the question answer session, if you have any question. Shubhanita Bulbul.
Sir, recording.
Okay.